This video provides an overview of the impulse winding tester. The impulse winding tester efficiently conducts electrical testing of coils in a non-destructive manner. It applies the same impulse voltage to both a standard coil and the coil under test, then compares their transient waveforms to determine pass or fail. A layer short occurs when copper wires within a coil short circuit. If there are scratches or pinholes in the insulation coating of the copper wire, current may flow between windings that should be insulated. This testing device applies a high impulse voltage momentarily, allowing for the easy detection of layer shorts that cannot be identified through tests like DC resistance measurement. When a layer short occurs, an excessive current flows through the affected area. If this overcurrent continues for an extended period, it generates heat, which can lead to product failure or even cause a fire. Impulse testing is highly effective in preventing defective products from reaching the market. The impulse winding tester allows for pre-checking the insulation strength of coil wires. Therefore, it is commonly used not only in production processes but also during development and prototyping stages. The detection of layer shorts is performed by comparing the waveform of the pulse voltage applied to the coil. A master waveform from a known good coil is registered in advance, and the test determines pass or fail based on the degree of deviation between this reference waveform and the waveform of the coil under test. To register a master waveform, first, prepare 10 to several dozen good coils. Next, select the coil with the most average characteristics from the group and register its waveform as the master waveform. The set voltage is applied to the target coil. When the voltage is applied, a waveform like this is displayed. The vertical axis represents voltage, while the horizontal axis represents time. This waveform consists of two parts, one showing the response to the applied voltage from the tester and another showing the resonance within the coil that occurs when the tester's output switch turns off. When determining layer shorts, the evaluation is primarily based on the degree of deviation between the master coil's waveform and the test coil's waveform within approximately 2 to 3 cycles after the tester's output switch turns off. This is done by comparing the area values of the waveforms. By applying a high pulse voltage for an extremely short duration, the load on the coil is minimized as much as possible. The DWX series comes standard with I/O control and RS-232C communication. Additionally, an optional LAN communication feature can be added if required. By utilizing the external communication function, the impulse winding tester can easily communicate with a PC or PLC not only as a standalone device but also when integrated with other measuring instruments in an automated inspection system. The tester's log data can be saved in CSV format on a PC using an optional CF card or the RS-232C communication function. When integrated into an automated inspection system, the data can also be automatically saved to a PC. Our impulse winding testers have been used by customers across a wide range of industries for over 40 years. They are widely adopted for testing industrial motors, automotive components, home appliances, and industrial robots. More recently, they have also been introduced for production testing of chip inductors used in smartphones. In addition to the domestic market in Japan, our testers have been implemented in overseas factories of Japanese companies, as well as by companies in the US, Europe, and Asia. If you would like to know whether our tester can be used with your coils or how the waveforms will be displayed, please feel free to contact us with any questions, no matter how small. Thank you for watching the video.